Hey, guess what? We are in our last video for Unit 1. Yay! So, our next video will be following our test, and it will begin in Unit 2. So, today, let's go ahead and talk about dilations and similarities and how it plays into the coordinate plane, meaning when I plot points. So what we have here is a picture of a cute little coffee cup. What I want to do is I want to take this picture and I actually want to dilate it with a scale factor of 2. So what you would do here is you would multiply each of the x and y values by 2. So 0 times 2 is still 0, so that would be my point here. 6 times 2 is 12, so this is my new point here. 8 times 2 is 16. And this point here is 8, 6, so that would be 16, 12 is my new point. Okay, so let's go ahead and connect those lines. So the lines that you see here would be the new picture if I dilated it with a scale factor of 2. Have you ever dragged a picture? So let's see if I can do this. Let's drag this picture. What happens if I don't keep it steady and I accidentally, right? It becomes all weird and stretched out. So it's very important that dilation you do all the same scale factor to all the points. Otherwise, if you were to blow this picture up and put it on a canvas or make a big 8 by 10 picture, it'll look all grainy and weird. So it's very important that you get that taken care of. Alright, so this time we wanted to dilate by a scale factor of 2/3. So this point is 0, 9. So I want to multiply 0 and 9 by 2/3. And when I multiply 0 by 2/3, I get 0. But when I multiply 9 by 2/3, I get 6. So my new point is 0, 6. Okay, this is 9, 0. So this would become 6, 0. And then I would have a point 6, 6. So my new line's here. Woo! I am not the best line drawer in the world. You would think, being a math teacher and all this practice, I'd be a lot better than I am. But I'm not. So anyways, let's fix that one. That one's bothering me. Still not great. Okay, well you get the general picture, right? So this should be 6, 6. Okay, and your teacher is an awful line drawer. Alright, so now when I have similar triangles, and I already know they're similar, we have to use the triangle proportionality theorem. Basically, we're going to take these triangles and extend them out and figure out what's up. So since I know that AOD is similar to COD, I can actually write that AO over CO is equal to OB over OD. Now I know that this distance from here to here is 2, because I went up 2. The distance from here to here is going to be 4. So that's 4. And this distance is 3, and this distance is unknown. Okay, now the reason I'm not going to use this small piece here is I don't want to know the length of this piece. I want to know the length of the whole piece, because then that'll tell me where D is supposed to be. So 2 over 4 is equal to 3 over OD. So we want to cross multiply. 2OD is equal to 12. So OD must be a length of 6. So if this length is 6, then OD must be 0, 6. Okay? So since D lies on the x-axis, its y-coordinate is 0. Since the length is 6, its x-coordinate must be 6. Alright, so given these points, let's go ahead and figure out. P is negative 15, 0. So the length of P to O is negative 15. The length of M, or not the length, excuse me, that needs to be positive, doesn't it? Distance can never be negative. Alright, M is 10. And to Q is 30. And this would be my unknown. Alright, so let's go ahead and write our proportionality. Cross multiply. Alright, so we know the length of ON must be 20. based on using my proportionality crossing. However, this point is in the negative direction, and so the x value must be 0 since it lies on the y-axis, and with it being 20 units long but in the negative direction, the value for n must be negative 20. I'm not supposed to say in there. Sorry guys. Alright, so we also need to know the scale factor. What's happening here is I'm multiplying by 2/3. So that is my scale factor. Alright, so let's go ahead and work on proving triangles similar. Remember that we've already learned angle-angle similarity, side-angle-side similarity, and side-side-side similarity. So what we're going to do is actually take these points and see, hey, what's up? So I'm going to get a line here because apparently I cannot draw a line. So 1, 5 is A, negative 1, 3 is B, C is 3, 4, so 3, 4. So that'll be my first triangle. Alright, and then we'll get a different color line. So I have E is 5, 3, and D is negative 3, 1. So what we're looking at here is we're looking at these two triangles, the red one and the black one. Okay? So first off, right off the bat, I see that these two triangles share this angle. So that's very important. I can either do angle-angle similarity or I can do side-angle-side similarity. I can find the sides with the distance formula, or I could even find the slope. So give me just a minute while I name my sides. So you could go the long way and do the distance formula, and, you know, find the length of AB, find the length of AD, find the length of AC and AE, and if it's proportional, then they're similar. However, I like using slope, so I can actually find the slope of these lines relatively easy. So I'm ignoring the directions and doing what I want because there are multiple ways to solve a problem. So if these two lines are parallel, they'll have the same slope. So the slope of line BC, okay, would be 4 minus 3 over 4 minus 3, 3 minus a negative 1, so that should be 1/4. Then the slope of DE should be 3 minus 1 over 5 minus negative 3 minus negative 3. So that ends up being adding. So we get 8 on the bottom, 2 in the top, simplifies to 1/4. Since these are the same, I know that BC is parallel to DE. And because of that, I can say that this angle and this angle are equal by corresponding angles. So angle ABC is congruent to angle ADE by corresponding angles. So I know that triangle ABC is similar to triangle ADE by angle-angle similarity. Okay? And it looks to be that the similarity ratio here, if this distance and this distance, what I am doing here is the similarity ratio would be 1/2 because the scale factor is 2. So 1/2 for my similarity ratio. Alright, so let's go ahead and prove that these two triangles are similar. I am again ignoring the distance formula and doing angle-angle similarity. So R is at negative 2, 0, S is negative 3, 1, and T is 0, 1. So that's my first triangle. And then the second triangle, I need a different color. we'll go negative 5, 3, 4, 3, and there. So automatically I notice they share this angle, and all I have to do is prove these two sides parallel. Well, they're horizontal, so that means that their slopes are actually 0, right? Horizontal lines have a slope of 0. And then, since, oops, I did not label my vertices. Give me just a minute. That's U, that's B, that's S, that's T, and that's R. So since I know that UV is parallel to ST because they both have the same slope of 0, then I can say that this angle and this angle are congruent by corresponding angles. So what that means for us is that triangle RST is similar to triangle RUB. So what that means is they're similar, and that has to be by the angle-angle similarity postulate. Alright, that is the end of Unit 1, folks. I will see you later.